If that arc is 240, what's the remaining arc?
120.
120. And why am I writing down 120 degrees for the central angle? What's the rule for a central angle? What's the rule for a central angle? Equal to arc. That's the type of justification that I'm looking for underneath each of these. And you jot down something that relates to one of our rules. What kind of angle is this? Inscribed. Can somebody tell me why it's inscribed? How do you know that that's inscribed and that that isn't? What is the definition that you have inside your head besides what it looks like? Give me something a little more mathematical. What makes that an inscribed angle?
Because the vertex is on the circle.
The vertex is right on the circle. And where is it? It's in the circle. Because you could have a vertex on the circle, but that angle is not totally inside, like number 5. So it's got to be inside and vertex right on the circle. Think about the rule. The rule is that the angle is half of the arc. What's that going to be? 68? Somebody raise their hand, tell me what's going on in number 3. Give me an answer for X. What are we looking at? All right, I'm going to write that down as add arcs, divide by 2. Why are we using that rule? What is forming this angle?
2 chords.
2 chords. So we're finding the average of those two. What's the average of those two? 119. It might be a good idea to also do this. Make an hourglass out of it, or a bow tie, whatever you want to think of it. The arcs at the end of the hourglass tell you information about what's inside the hourglass. You might have to answer a question that requires you talking about that angle. Don't forget everything you've learned during the year. What kind of angle pair are right next to each other along this chord? Supplementary, linear pair, however you want to think of it. So sometimes you might be finding this, you might be finding this arc on the outside. Just be aware of where things are. On this page, we're assuming that if there's a dot in the middle, that that's the center. That's normally not a good thing to do on your test or quiz, whatever. I think we just have one more test in chapter 10. No more quizzes. It will be obvious that that's the center. I'll either name the circle or we'll say that that is the center. Right now, that's the center. Which means that this is the diameter. Which means that it cuts the circle in half. Which means that you've got 180 degrees to deal with for your semicircle. What's left for X? 114. What did you write down underneath?
Diameter.
All right, you might have written down diameter. That helped you do the problem. What kind of angle were you looking at? That's the central angle. You could have written that down. Just give me something that's a justification. What are we looking at in number 5? What did we call that in our rules up on the sideboard? This is a chord tangent angle. What is the rule for a chord tangent angle? Arc's double, or the angle is half of its arc. So which is gonna be bigger? The angle or the arc?
Or the arc.
248. Number 6, where is the angle, inside or outside? Outside. What's the overriding rule when you've got an exterior angle that's formed by some sort of combination of tangents and or secants?
You subtract the arcs and divide it by 2.
Subtract arcs, divide by 2. That's off of our angles and arcs worksheet. So I'm taking 109 minus 53. Don't forget to divide by 2, and that should give you that. Is that 28? Is that right? So that's 28 degrees in there. Number 7, when we did this on Circle Basics, it looked like this. Do you remember that diagram? And we said that this was equal to this was equal to this, and this was equal to this. That is one of the green rules up there. It says distances from an exterior point. Here's your exterior point. And I'll get rid of this. It wasn't there. Distances from exterior point to a point of tangency are equal. So that will always equal that. That's not helpful here. Sorry. But I just wanted to point that out. Why isn't it helpful? Because we're not dealing with distances, we're dealing with arcs and angles. If that's 260, what's left here? 100. And the overriding rule is still this. Doesn't matter if it's secants, tangents, or a combination of tangents and secants. You're still going to do subtract arcs, divide by 2. 80 degrees for the exterior angle. What kind of angle is this? Inscribe. We know that that's half of its arc. What arc? The arc that it catches, the arc that it intercepts, the arc that it traps. We don't know that one. How can I figure that out? If that's the center. $180 degrees. This cuts it in half. You're left with, is that 82 up there? And X would be 41 in there. What's this little snippet right here? 76? And now it's just like the problem right above it. Subtract arcs, divide by 2. You take the 114, you take the 76, divide by 2. What is that? Is that 38, 19? And that is that. If I want to use add arcs, divide by 2 for this, then I have to think about this bow tie or this hourglass. So I need this if I'm going to do it directly. What's left for that little blue arc section? 124? Now I can focus on those two, 136, 124 divided by 2. That is 260 divided by 2. 130 is that angle. Anybody do it a different way? Could I have focused on this bow tie, that would have given me 50 degrees for inside that hourglass. And it's supplementary to the X, which would have given me 130. Now we're getting into some problems where maybe you're not looking for the angle. Maybe you know the angle and you're looking for the arc. If you can't do this in your head, write out the entire formula. Write out the entire equation. You know what are you supposed to do with the arcs in this case? It's another subtract arcs situation. What are the arcs? The arcs are 146 and x. You're supposed to divide by 2. And what is that supposed to equal for? The angle, 26. So you're working backwards from that equation. How do you get rid of the 2? Times it by 2. So 146 minus x is now equal to 52. You do whatever it takes to figure out what x is. What are you going to subtract from 146 to get you 52? How much? 98? 94?
Yeah.
What is this that touches the circle once? Tangent. What is this that is trapped in here and is a segment? That's a chord. We got a tangent chord situation. What's the rule for tangent chord? Half of arc. Arc is double the angle, so this must be 144. Is that right? Well, we need x. What's left over for x?
216.
216. Looks like we have another diameter here, but what's part of a diameter? Radius. The way we wrote up the rule was that if we had a radius and a tangent, that's the first green rule on the sideboard. What resulted from that? 90 degrees. Or you could look at that as a chord tangent situation. That's a chord, it just happens to be a diameter. What's the rule for chord tangents? Half the arc. If the arc happens to be 180 degrees, what's half of that? 90. You look at it two different ways. We've got a chord, two chord situation. What do I do with the hourglass? Add arcs, divide by 2. So what are the arcs? I got 13 plus x divided by 2 is going to give me 11. You could do this in your head. Really, you need two numbers whose average is 11. That means that has to add up to 22. That means that x is 8, 9, 9, 9. Is that right? What are we looking at here? I've got a tangent and a secant. What's the rule for an exterior angle situation? Subtract arcs. I need to know this arc, 83, and that is 208. 198? How's that? Is that right?
Yeah.
8, 9, 1. Do a little subtraction. 162, 83. What's that? 79.
Yeah, that's right.
How's my arithmetic?
X equals 39.5.
Are we getting a decimal out of this one?
Yeah.
Decimals are your friends. X degrees equals 39.5.
Yeah.
Degrees. Degree symbols are going to be important. Make sure that if you're talking arcs and angles, you've got the degree measure. Make sure when you're looking at page 2 that you're talking about lengths and distances.
No.
As soon as I see problems that have distances and involve secants, I immediately do this. Put some brackets in because I know I'm going to have to determine a whole either number or algebraic expression. Sometimes it's given to me, sometimes it's not. In this case, I don't have something to call this distance yet. What do I want to call that distance? Since I have the numbers in front of me. What's the whole secant? 14. 3, 11, 14. What am I going to call this one that has two chunks that are 6 and x? Now I have something that I can use for which of my rules? What's my rule? Whoa. Whole times outer, whole times outer. 14, what's the outer for the 14 secant? 3. X plus 6. I'm going to write it as if it was distribution. Does it matter if I'm writing whoa or ow? No. So I put the outer portion first just to make it look nicer. I'm still multiplying it. Make sure you're doing distribution. 6x plus 36. 6x equals 6. X equals 1. What is that? It's a distance of 1. Whatever it is. 1 meter, 1 inch, 1 centimeter. That's equal to 1. That was a whoa. What's the rule for two chords and a bunch of segments that are resulting? And right now we're putting that into quotes because we really haven't learned where it comes from. We know that it comes from a proportion, but we haven't proven it yet. But we can still use it. That means that 3 times x is going to be equal to 9 times 2, which means that x is 6. What is it? It's a length. It's a distance. This was the one that I wanted to point out was like the problem we did in circle basics. That's the one. But we're just not seeing the entire triangle. We're just looking at one exterior point coming back to 2 points of tangency. They've got to be equal, so you're setting them equal to each other. What did we find? We found...
Why do they have to be equal?
Remember when we were doing... Remember when we were doing that on Circle Basics, and we had a situation where we had right triangles. We proved that this was equal to this because the radius is equal to the radius. And if they have a common hypotenuse, if you remember back to chapter 4, wasn't HL one of the ways we proved that 2 triangles were congruent? Because of HL, they're congruent. If they're congruent, then by CP, CTC, That distance is the same?
Okay.
And that distance is back to the circle. So I could make triangles over here just as easily and do the same thing. What should I immediately do since I'm looking at a secant and a bunch of lengths? Brackets. Or bracket. What am I going to call that distance if that chunk is 6 and this chunk is x plus 2? X plus 2 plus 6, which is x plus 8. What is the rule for a tangent, secant, segment situation?
T squared.
2? A 2 situation?
Yeah.
What gets squared?
12.
12. 12 is the tangent portion. The whole we said was x plus 8. I'm just going to show it as distribution. The outer is which piece? What should I multiply this by?
6.
6. So I've got 144, 6x plus 48. Do a little subtraction. 96 is 6x. X equals 16. Does that look right? What did I find? I didn't even find a segment length. All I ended up finding was what the value of the variable was. If I needed to know the length of the chord would be 18. If I needed to know the length of the entire secant, then that would be 24. Pay attention to what's being asked for. On here, it just said find the value of x. Put in some brackets. What's this bracket distance? 14. What's this bracket distance? X plus 5. Sometimes you're given this information. You know how to deal with different problems. Read what's in front of you. What's my rule? Whoa, whoa. 14 times 4, x plus 5 times 5. 56 equals 5x plus 25. Is that right? Is that 31? What's 31 divided by 5?
6.2.
Is that exact?
Okay.
6.2. What's my rule for a 2-chord situation looking at segments? Do some cross multiplication. 8 times 5, 2 times x plus 4, 2x plus 8, 2x equal to 32, x equal to 16. And what is that? That's just a variable, just a value. What's my overriding rule for tangent, secant, and distances? You've got to keep separate things like this and this. When you got tangents and secants and distances, that's a 2 rule. When you've got tangents and secants and you're dealing with angles and arcs, you're going to be subtracting arcs and dividing by 2. 2 separate ideas. I'm squaring x this time. My whole is 36. 36 times 4. Is that 144? So that would be 12. Next year, you'd have 2 answers. 12 and negative 12. But does negative 12 make sense for this? No. So we just deal with positive. Same situation, we have a 2 situation, so 8 squared, 4 times x plus 6. x equals 10. Is that right?
That's good.
10.
Let me see what you
We squared 8, and then we did x plus 6 as the whole times the 4, which is the outer. That gave me 4x plus 24. I subtracted 24. That gave me 40. Divided by 4 is 10.
Where the heck that 6 come from?
X plus 2 plus 4.
The whole.
Oh, I was looking at the wrong problem.
I'm getting 8x equals 24, x equals 3 for number 9. I'm looking at another whoa for this one. What are you calling this whole?
X plus 4.
X plus 4. The mistakes we're seeing, people are just mushing them together and saying 4x. Would you multiply these two to find the length? No. The whole is the sum of its parts. Sum. And that's 14. So 14 times 5 equals 4 times x plus 4. 70. 4x equals 54. What is that?
13.
13.5? Is that exact? 12 page.
I just don't get number 8.
8?
Like when you multiply 4 times the x and get 4x, and then multiply 4 times the 2 and get 8.
We're not you gotta do, here's the rule, whole times outer. X plus 2 is not the whole, x plus 6 is the whole. You have to add x plus 2 plus 4 to get this whole thing. This is just the chord, and that's not part of the rule.
Oh, okay.
Got it?
Yeah, I get it. Shut up, Eric.